Let's revise, Safia, what we studied in the last lecture. Okay, so first was the cornea. Cornea is the first of eye. Okay, this is the first uh, outer surface of the eye. Okay, outer surface of the eye which protect the eye from the foreign material. As I told in the last lecture, protect the eye from the foreign material, just like plasma membrane does to the cell. Right, it protects the cell from the foreign material. Right, and it also does what? Reflects almost 80% of the light that is incident on it. That is incident. It helps in, I mean, we can say in this way that it helps the lens. It helps the lens. It because the work of lens is also to refract the light, but most of the light that is refracted is caused by cornea. Almost 80% of the light in the starting only. It is refracted by cornea. Then second is the aqueous-humor. Aqueous-humor is what? It maintains the pressure. It maintains the pressure inside the eye, and it has water-like consistency. Iris and pupil does the work. They simultaneously do the work. Means they work in pair. So iris is the muscular diaphragm. This is the iris. This third one is the iris, and the opening part is the pupil. Pupil remains black in color. Pupil remains black in color. You must have seen your eyes inside it means one part is the one is the black of the eye, right? Black of the eye, and inside that it's one that is always in black color. Means the this you can say the iris of the eye. The iris of the eye is sometimes it's colored. It's brown. Sometimes it is green, gray, right? Someone's eyes में किसी की eye green होती है, किसी की gray होती है. It's like no. So but the pupil always remains black. Why does it so? Why is it so? Pupil always remains black. Why? Because all the lights in this no all the lights get refracted. No, none of the light is reflected. Means no any light gets reflected from this pupil. That is why it remains black. That is why it remains black. It regulates the amount of light entering the eye. Okay, can you please switch on your camera, everyone? I forgot. Can you please switch on your camera?
Ma'am, then give me 5 minutes. I'll just.
Why 5 minutes?
Ma'am, because I had to wash my face.
Safia, please switch on your camera. We have to finish it fast. We have to increase our pace. Okay. Okay, fine. Got the you already have gotten the concept of iris and pupil, Safia. Iris and pupil के बारे में सब पता है ना? That iris is just like a gate and pupil is just like an opening. Okay. Iris एक गेट की तरह है, pupil एक ओपनिंग की तरह है. जब लाइट ज्यादा आती है तो क्या होता है? रुद्र हेलो. जब लाइट ज्यादा आती है, when lot of light comes, then iris both of the iris come closer towards each other. Okay, come close towards each other. And जब लाइट कम आती है तो both the iris get far from each other in order to open the opening. Means that is pupil. Okay. Crystalline lens, it reflects the light. It reflects the light. It focuses the images on the retina. Okay, fine. It focuses this is our crystalline lens. It focuses the image on the retina. This is our retina, the blue part, the eighth part. Okay. Now, after crystalline lens, yes, ciliary muscle and crystalline lens work in pair. Crystalline lens and ciliary muscle work in pair because whenever when the eye lens has to become elongated, means like thin, then the ciliary muscles get contracted, and when it has to become thin, then it will the ciliary muscle will be contracted. Okay, दोनों तरफ से खींचे रहते हैं ताकि ये क्या रहे? Thin रहे. Okay, and this when it has to become thick, when lens has to become thick, when we see the nearby objects, then lens has to become thick, and when we want to see far away object, then lens has to become thin. Okay, and when it is thick, then ciliary muscle are in relaxed position. Okay, getting? Okay now retina with ciliary muscles and crystalline lens. Jaldi kar rahe hain. Okay, fine. Because this already I have done. I am just revising it. Okay. Vitreous humor is what? It has honey-like consistency, just like honey. It is same as that of the aqueous humor, but aqueous humor has the water-like consistency, but the vitreous humor has honey-like consistency. Okay, it maintains the spherical shape of the eye. It maintains what? The spherical shape of the eye. It applies the pressure on each of the on the walls of this eye. Okay, it so that the spherical shape of the eye is maintained, should be maintained. Okay, so this is our vitreous humor, which is responsible for what? Which is responsible for maintaining the shape of the eye. Okay, fine. Now retina, where it is a photoreceptive cells. It has two kind of cells, not two cells, but two kind of cells, that is rod cells and cone cells. Okay, rod cells and cone cells. Rod cells is responsible for receiving means is what we say. Okay, is responsible to judge the intensity of light. Okay, towards the intensity of light. It is active towards the intensity of light, and the cone cells is active towards the color of the eye. Because of cone cells, we can see the different type of colors around us. Okay, and intensity of light means we can also see the things in dim light. We can also see the things in candle light. We can also see the things in what tube light, and anything means we should it's not important that there should be only sunlight to so that we can see. So we can see in any of the light, we can see in dim light also. Okay, so rod cells is responsible for that. It is photoreceptive cells, and here the images are formed. In this, the images are formed in this the eighth part. Shazan, you are getting something now. In the from the uh, this is the retina where the images are formed. Okay, where the images are formed. Now the the another thing is optic nerve. Optic nerve is responsible for changing the optical signal that is coming towards us in electrical signal and send it to the what? Brain to interpret it and does what? Interpret it and send the information to the brain. Okay, it changes what? Optical signal to the electrical signal and send the information to the brain, so that it can tell us that you are seeing this object. Then we say that yes, we are seeing this object. Okay, if optic nerve will not work, and it will not send the information to the brain, then we cannot see it, because it's only the brain that is telling us that you are seeing this thing, right? When the images are formed in the retina, then the optic nerve is responsible for sending it to the converting it to the electrical signal, and then send the information towards the brain, so that we can so that it can interpret and tell us that this object is being seen by us. So blind optic nerve. Okay, fine. And blind spot. Blind spot is what? Where no rod cells and cone cells are found. Here, no rod cells and cone cells are found. We cannot see the objects. We cannot see the images formed at this point, because images are formed, but we cannot see the objects, because we cannot see the images because we cannot see the object because there no rod cells or cone cells are found. Okay, means it cannot tell us about the intensity of light. It cannot say about tell us about the color of the light. So whatever the images will be formed, will not able to see that image. Okay, and sclera is the white part of the eye, which we can see clearly from even from our naked eye. Okay, it's the white part of the eye. Now we are going to study today. There are some of the notes, that is this is what iris regulate the amount of light entering the eye by adjusting the size of the pupil. That what should be the size of the pupil, what should be the size of the pupil, how much it should come closer to how much the iris should come closer to each other to close it or open the pupil. Okay, so iris regulates the amount of light entering the eye by adjusting the size of the pupil. The pupil appears black because no light reflected by it. That I already told that pupil is always black in color. Okay, is always black in color because no light gets reflected from it by it. The eyeball is nearly spherical in shape. Okay, eyeball is nearly spherical in shape and has 2.3 centimeter as diameter. And in any of these does not work very clear, does not work good, then it will be result in visual impairment. We cannot see the object very clearly if any of these will get defective. Formation of an image. Okay, color of the object, and this already been discussed, that rod shape of retina respond to the intensity of light. Okay, how intense the light is, the degree of brightness or darkness, but do not respond to colors. Rod cells are not responsible to respond to colors. Okay, the cone cells are sensitive to the different extent of primary colors, such as red, blue, green, whatever we see around us. Okay, Now the terms, not the terms. As I said in the last lecture that accommodation, power of accommodation is very important, right? Power of accommodation is very important. So to understand power of accommodation, accommodation means to adjust. Okay, how the eyes get adjusted towards the objects that we see in far away. So कुछ far away objects होते हैं, कुछ पास में object होते हैं, and eye gets adjusted according to that, right? Our eye lens gets adjusted according to that. So how this is going to be done? How this is done? So this will be power of accommodation. Rudra, hello, Rudra. Rudra, can you understand English? Sorry, can you understand Hindi?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. You speak so slow. Why do you speak so slowly? Your voice is so slow. Okay. Power of accommodation. I have written the wrong spelling. Power of accommodation. Okay. अब हम लोग देखेंगे कि power of accommodation, what does it mean? So accommodation means to adjust. Okay. And what is adjusted in this? What is adjusted in this? Adjustment of focal length take place. Adjustment of, मेरी writing अच्छी नहीं बन रही है, वैसे मेरी writing अच्छी है लेकिन बन नहीं रही है. Adjustment of focal length take place. अब now how this adjustment of focal length takes place? Okay, we want to see clearly every object. You expect from your eyes that it should make you see every object clearly. Is it so or not? Do you expect this from your eye or not? तुम चाह रहे हो कि नहीं कि तुम आई से सारी चीजें क्लियरली देखो, चाहे तुम पास देखो चाहे तुम दूर देखो, everything should be clear or not? So to everything, please switch on your camera. Shazan, it's already 20 minutes. Your camera is okay. Rudra, your camera is broken, I guess. You said it, right?
Yes, ma'am.
Okay, fine. So power of accommodation. अब हम लोग पास की चीजों को भी क्लियरली देखना चाहते हैं, राइट? एंड दूर की चीजों को भी क्लियरली देखना चाहते हैं. दूर की चीजें कैसे आती है? पैरेलल आती है, पैरेलल बीम ऑफ लाइट, राइट? पैरेलल बीम ऑफ लाइट. ओके, एंड दिस पास की चीजों से this kind of what kind of light is this? What do you say? Diverted light. Means like it's coming towards us like diverted light, right? So now we want to see both type of objects clearly. Both type of objects clearly. That is placed near us or it is far from us. Even if we want to see see our phone, then also we want to see it clearly. And if we want to see the wall or someone that is who is far from us also clearly. So where should the images should be formed? So it means that if we want to see all of the objects clearly, then it means the images must be formed at the retina. रेटिना में दोनों टाइप की इमेजेस फॉर्म होनी चाहिए, चाहे वो दूर से आ रही हो या पास से आ रही हो. इमेजेस कहाँ फॉर्म होनी चाहिए? रेटिना पे फॉर्म होनी चाहिए, राइट? रेटिना पे फॉर्म होनी चाहिए. मींस दिस our images, we want our images to be formed at retina. Now how can it be possible? Now this is very easy. If something is coming from far, then it will because it is a converging lens, right? It is a converging lens. What is it? The convex lens is a converging lens, as we already are knowing. So it will easily converge. It will easily converge the rays on the retina, all the rays on the retina, and we'll get a sharp image of the object on the retina, and we can see the object, right? We can see the object clearly. So because it's very easy, it's coming from far and it has got converged at a point that is on the retina. Okay, and we can see the object. Now if we want to see this type of images, this type of object, means the object that is near to us clearly, then what should be the focal length? Then what the focal length should be? It has to adjust itself now, so that we can see the object clearly once the images will form that retina. So it has to become this focal length, this first this has to become what? A more thick. Why? So that it will become more powerful and it can converge this diverted rays also into at a point. Because if this will if this lens will remain as it is now, what it can do? It can just make the rays parallel to each other, or meet at some point very far from the retina, if it will not get adjusted. Very far from, and we'll get a blur image at the retina. But it's not so. It gets adjusted. See, if we want to focus all the images at retina, it means that our V is constant. Our means we want our V to be constant. V अगर constant रहेगा, right? Then only we can we can see the object, because then only the objects will then only our the image of the object will be seen here, will be the image of the object will form here. Means we should be constant at every point. Means even if the object distance is changing, even if the object distance is changing, like object distance is changing, means here it's coming from very far, right? Here the rays are coming from very far. यहाँ पे बहुत दूर से आ रही हैं, यहाँ पे पास से आ रही है. The u is changing. U is this, like object distance is u, right? As already we have studied in the ray optic, means in the last chapter in the lens, what we studied, that this is the object distance is called the u, right? And this is also u, this is also u. U is getting changed. U is getting changed. And here it means for here u is something else, for here u is something else. But we want our v to be constant. V should be here. Even if we are seeing the far away object, even if we are seeing the nearby object, we want our v to be constant, because the v distance it will be the same. The distance from eye lens to the retina. Distance from eye lens to the retina will be the v distance, right? It should be constant. Then only means images should be formed here. Everyone is understanding my point or not? V should be constant or not, so that we can see the object clearly. What is the v distance? What is the v distance? This is our v distance. Now, if some objects are coming, this is our v distance. Now, this is what we call as v. That is image distance. Image distance को v कहते हैं ना, Rudra? Are you there?
Yes, ma'am.
So understanding or not?
Yes, ma'am.
We want our v to be constant or not?
Yes,
Even
ma'am.
if we are seeing nearby objects or faraway objects, we want our v to be constant. If we are already knowing about the formula, that is 1 by f is equal to 1 by v minus 1 by u, right? We are knowing this formula. Are we knowing or not? The lens formula. This is the lens formula, right? So we want our v to be constant, because we want the image of the object to be formed at retina only, even if we are seeing the object kept anywhere. Okay, object is kept anywhere. We want v to be same. Okay, what if okay, now tell me, v will be constant and your u is changing. Why? Because you are seeing sometimes far away object, you are seeing sometimes what? Nearby object. Okay, your u is changing. Will your f be constant? Will your f be always constant? Can it be possible that your v is constant and your u is changing and your f will be constant? Can it be possible? Can it be possible? In the table of 2, 2 3s are 6, 2 4s are also 6. Is it so? Means your 2 is constant in the table of 2. You are changing this 3 part, you are changing this b part. Is your c part constant? Is the answer that is coming out to be is constant? No. It will also change, right? It will also change as you are changing the other value, the second value, the third value is also getting changed, because the first value is constant. Since the first value is constant, okay, let it be constant. Your second value, there are three values. Your first value is constant, okay. Your second value is changing. Will your third value be constant or it will change? Tell me, Safia. Will your third value remain constant or it will change?
Yeah.
What?
It will change now.
Will change, right? So means f will change, right? F will change according to v, according to u. Why? Because u is changing. V cannot change. Okay. Image distance cannot change, because we want our image to be formed at retina, and distance from retina to eye lens is fixed. This is fixed. This will not change. Okay. What can change? U is changing. Though u is changing, so f will change. U is changing because u is getting changed, as we are seeing the objects kept at different places. If u is changing, v remaining constant. Shazan, you are getting or not, or you are confused?
I'm getting it. I'm getting the previous chapter. This 1 by n equal to 1 by v.
Since this u is changing, this f has to change. F has to change, right? This is called power of accommodation. F is getting changed, means the focal length is getting changed. If focal length is getting changed, it means what? Focal length will, how the focal length will change? How the focal length will change? By this is your lens, crystalline lens. Okay. this you are seeing nearby object, it will change itself. It will change its focal length. Means ciliary muscle do what? Ciliary muscle will comes to its relaxed position, and it will change its relaxed position. Means it will leave the grip of this. If it will leave the grip of this lens, it will become thick. And now it has become thick since its focal length has got reduced. The thick lens will have small focal length. The thick lens will have small focal length. Okay, thick lens will have focal length small. Then only power will be large. Then only power will be large. Why? Because the formula for power is 1 by f. They are inversely proportional to each other, right? They are inversely proportional to each other. f छोटा होगा तो पावर बड़ा होगा, और पावर बड़ा करना पड़ेगा बिकॉज हमको नियर बाई ऑब्जेक्ट देखना है. डाइवर्टेड लाइट आ रही है, तो इसको क्या होना पड़ेगा? मोटा क्यों होना पड़ेगा? मोटा होना पड़ेगा so that it can converge the light and form the image at the retina, so that it can converge the light, because already the diverted light is coming. It has to converge the light in order to form the image at the retina, so that we can see the objects clearly. So it has to become fat. It has to become more powerful. Powerful means focal length chota. Focal length chota means power bada. Okay, focal length chota means power bada. समझ रहे हो ना? Power ज़्यादा. Okay, and when we try to see the faraway objects, then already the light is coming parallel. It can easily converge it to the point. It can easily converge it to the retina. Okay, it can easily converge it to the retina. The ciliary muscle will be in contracted position. It does not want its focal length to be small. It does not want its power to be large. Its power to be more. The focal length will be large. It means the power will be small. It means the power will be small. With the small power, it can converge the light that is coming from far. Means the parallel beam of light that is coming towards it. It can easily converge it to a point on the retina. Okay. This is called power of accommodation, that the adjustment of the focal length of the eye lens. The focal length of the eye lens get adjusted according to the object kept at different places. Got it? Power of accommodation, right? Understood or not? Rudra, understood or not? Power of accommodation.
Yes.
Power of accommodation.
Yes.
See, the object parallel rays of light are coming from distant object. So ciliary muscle will be relaxed. Ciliary muscle will be relaxed. Then F will be what? Small. Power will be what? High. Power will be high. Why? Because P is equal to 1 by F. Okay. Less will be the power. Less will be the focal length. More will be the power. Okay. Thick will be the lens. Less will be the focal length. Less will be the focal length. More will be the power. Understanding? Getting everything? Eye lens is thin. Focal length is large. Yeah. Here, eye lens is thin. Everything is written here. Ciliary muscle relaxed. What is written here? Focal length is large. Eye lens is thin. And here, eye lens is thick. Focal length is short because the light is coming from nearby object. Okay. I already have made this here, so you better refer this. Okay. Okay. So V will be constant, and your here 1 by F is equal to 1 by V minus 1 by U. U will change, so focal length will change. F will be for this light coming from nearby object. For this F should be small and power should be large. Okay, and for this F should be large, power should be small. Okay. The ciliary muscle help in changing the curvature of the eye lens. When muscles are relaxed, the lens become thin and its focal length is increased. Okay, this enables us to see distant object clearly while viewing the nearby objects. The ciliary muscles contract, so the lens becomes thicker and its focal length decreases. It will contract. The lens will become thicker. It will contract. Okay, and that I just told you. Here something I guess was okay. Where I told this thing. Yeah. So once it will be relaxed, it will be stretched. Means it will be thin. If it will be, it's in contracted position right now. When we are seeing the objects from nearby, it will be in contracted position. So that it will contract, so that it will become thick. The focal length will become small and power will become large. Okay, and once the rays are coming from faraway objects, then also V has to be constant. Okay, then the images, then the ciliary muscle will be relaxed. Ciliary muscle will be relaxed. Okay, ciliary muscle will be relaxed. It will be what? Thin. It will be what? Thin, and focal length will be large and power will be small. Okay, always remember this thing, that thin lens will be having large focal length. Will be having large focal length. Okay, thin lens will be having large focal length. Okay, and thin lens, large focal length, and thick lens will be having small focal length. Will be having thick lens, small focal length. Okay, now what is it? Another point. Far point of the eye. Far point of the eye is infinity. We can see the things up to the infinity. We can see the stars, right? We can see the stars clearly. So our far point is infinity. Okay. We can see the objects kept at far, means kept at infinity also. Means we can see the stars. We cannot see the black hole. Don't ask for the black hole. Okay. We see about things that is we can see. Means okay. So far point of the eye is it is infinity for the normal eye. I'm talking about the normal eye right now. Okay, not my eye, not Safia's eye. Okay, I am talking about the normal eye. Okay, fine. So near point of the eye, near point of the eye is what? 25 centimeter. What is it? Near point of the eye is 25 centimeter. Up if a normal eye will see, it can see the things kept. Means like if we are reading a book, then we can see the things clearly, and without the eyes getting strained, it will we can see the object kept at 25 centimeter clearly. Okay, it will be what? Near point of the eye. This is called near point of the eye, and also called least distance of distinct vision. Least distance of distinct vision means the minimum distance of distinct vision, means when we can see the objects very clearly. Every object clearly means every letter should be clear. We can see the objects even if it is 20 centimeter, but the eye will feel strain. I will feel strain. It will has to become more thick. It will has to maximize its power. Okay, it will have to maximize its more power. So we will feel strain, and it will lead to headache also. Okay, so the near point of the eye is 25 centimeter, where eyes feel no strain in seeing the things, and it can see the things distinctly also. Persistence of vision. Have you seen the cartoon? कार्टून देखते हो तुम लोग? देखे हो कभी? कार्टून देखे हो ना? तो कार्टून में क्या होता है? बहुत सारे मीन्स लाइक there are so many of images that get flashed before your eyes. Means like 16 to 20 to 25 images gets flashed in 1 second. Then we can see the things that have our हाथ ऐसे जा रहा है. In the first image, our hand will be like this. In the second image, our hand will be like this. In the third image, our hand will be like this. So at every means like there will be 16 and more of the images that will be flashed in front of you in 1 second. Then we can see that a video is going on, like हमारा हाथ ऐसे चल रहा है. समझ रहे हो? तो क्या होता है कि 1/16 सेकंड के लिए हमारी आंख जो है कोई चीज को परसिस्ट कर सकती है, कोई इमेज, कोई ऑब्जेक्ट के इमेज को परसिस्ट कर सकती है, अपने आंख के अंदर रख सकती है. सो 1/16 ऑफ द इमेज के लिए एक हम इमेज देख रहे हैं, ऊपर सेकंड में 2/16 ऑफ द सेकंड में दूसरी इमेज आ गई, 3/16 ऑफ द सेकंड में तीसरी इमेज आ गई. तो इस तरीके से इतनी जल्दी इमेजेस को फ्लैश कर देते हैं कि हम लोग को लगता है कि एक वीडियो चल रहा है, राइट? We feel as if some video is running before us, but it's not the video. It's just a bunch of images that get flashed in front of our eyes. Okay. If time would allow us now, to I would have shown you one video in the YouTube about persistent of vision. I've seen that it's very interesting and it's very clear. I mean, the concept of persistence of vision will get clear to you once you will see that video. Okay, so but we don't have much time, so I cannot do that. So it's not very important. Like, so you can just see, you can just keep one thing in your mind, that the time from which the impression of the image persists in our eyes. Okay, that is known as what? Persistence of vision. The time for which the impression of the eye of an object continues to remain in the eye. Okay, continues to remain in the eye is called the persistence of vision, and it's about 1/16 of the second, which means that the minimum time for which we should view an object so that its clear image is formed on the retina, its clear image is formed on the retina is 1/16 of the second. If someone will show you something for 1/16 of the second, the image of the image of that object will be formed on your retina. Okay, will be formed on your retina. Okay, so why two eyes? Why two eyes? Why do we have two eyes? If from one eye we can only see up to the 150-degree, right? Close your one eye and see the object. Try to see in your surrounding. You can see only up to 150-degree. You'll notice that you can only see up to 150-degree, and if you will open both of your eyes, you can see up to 180 degrees. Means the whole thing that is just not behind you but beside you in the left and beside you in the right. Okay, you can see up to 180-degree with two eyes. Only 150-degree we can see from our one eye. Okay, and also it means that it gives a wider field of view. Okay, if one eye would okay, the ability to detect faint object is enhanced with two eyes. Also, if an object is if you are seeing an object from one eye, it will get clear. It will get clear. The quality will get clear once we'll see from our two eyes. Our eyes are separated by a few centimeters, and each eye sees a slightly different image, right? Because they are at different places, means they are at few centimeters separated. So our eyes will be both of the eye, the lens, both the lens of both the eye will form different images, right? Will form the images at different places. But our brain does what? The brain combines the images and let us see one image of the object, and due to which we can see only one object. Not means there are two eyes. We have two eyes. We don't see the two objects always. We see just one object. Why? Because brain interprets the two images and then it tells us that here is your object, and it shows us only one object. Okay, tell us how close or far away the things are. The two eyes enables to judge the distance more accurately. From the two eyes, we can judge the distance more accurately. Keeping both the eyes open provides a third dimension of depth, and also we can know about the third dimensions. Okay, the depth we can know from the two eyes. Okay, so first topic is done. Rudra, your exam is going to get started, right? Hello.
Oh, yes, sir.
Your exam is going to get started, right?
From September, yeah.
From September
16th.
16th. And Safia, yours?
Mine is starting on the 12th of September.
September 12th. Okay. Now how much classes we are going to get? This is today's 24, so we'll get not on Friday 2nd. We'll get on 2nd. We'll get on 9th, and the another one we'll get on 16th. Oh, and from 16th means two more classes we are getting. After take one exam, in two more classes we can and yes, Safia, what is your third chapter in the school? Is it electricity?
Yes, ma'am, I do. It's electricity.
In the school, has it got started?
No, not yet.
Not yet. Okay. Means it's still this I is going on.
Yeah.
Okay. And in your Rudra?
We finished electricity. We are doing mathematics.
You have finished electricity in the school.
Yes, sir.
Okay. Okay. From in the I will keep one extra class to finish this chapter, to finish this defects at least. Finish this. I will take one or two extra classes. Okay. I will arrange that and then we'll let you know. Okay.